Hi, Math0965. Welcome to 6.6, our last section with solving quadratic equations by factoring. So we begin this section by looking at solving linear equations. And so you have looked at equations like this where you are asked to solve for the variable, typically x, and our goal is to isolate x. So when you get a problem like x plus 5 equals -3, you are subtracting 5 to both sides of the equation, and your answer is -8, right? So x equals -8. This should look familiar, whether you have x on one side or on both sides. When you have it on both sides, you want to gather the variables to one side and the constants to the opposite. And so in this problem, I can subtract 5x to the left-hand side if I want the variables on the left. And since the variables are on the left, that means my constants will be on the right, right? When we solve this equation, -3x equals -11, right? And when we lastly divide by -3, we get a fractional answer, right? X is equal to 11/3. And so a little review for solving linear equations. In this section, when we are solving quadratic equations, we are going to use a couple different principles when doing this. The first one is going to be the zero product property. And what a zero product property says is that when two things are multiplied together, right? Something times something and it equals 0. One of the beautiful things about zero product property is that we know either one or the other or both are equal to 0, right? So we use this fact when we are solving quadratics. When I say quadratics, we are referring to anything that has an x squared term as its highest power, right? So when we look at problems like A, right, if I FOILed that, the very first term would say x squared. So we know this is quadratic. Now, we can use zero product property here if I look at it like this. Something times something else is equal to 0, right? We know one of those things, either x minus 6 is 0 or the x plus 4 is equal to 0, right? One of those things is definitely true. So when I solve, I have an x equals 6 or an x equals -4, okay? When we write these answers in MyMathLab, typically you are writing them in set notation, and so you can just list these answers as 6 and -4. Later on, when we're looking at quadratics and their graphs, what we're going to see is that these answers that we are getting here are actually the x-intercepts. These are where the quadratic will cross the x-axis at these points, 6 and -4. All right, so let's take another look, right, at a problem that is similar. If you go to letter C, okay, something times something times something is 0. Now, one of those somethings is definitely 10. So it doesn't make sense to say 10 equals 0. We know 10 doesn't equal 0. 10 equals 10, right? And so we are looking to set something that has a variable, right? Namely the x minus 4 equal to 0, right? Or the other set of parentheses, 2x plus 9, and set them equal to 0, right? So when I solve these, x is going to equal +4. That is one of my answers, right? Or here, right, 2x equals -9 when I subtract 9 to both sides of the equation. And then when I divide by 2, I end up with a fractional answer here. X is equal to 9/2. Okay. When you are getting fractional answers in this course, go ahead and keep them as improper. I don't need to change them to a mixed, like -4.5, or a decimal, -4.5. We actually prefer you to keep them as improper fractions. Okay, so let's keep going. We've looked at problems that use zero product property. So the thing with zero product property is that they have to equal 0. And I look at the next problems, right? They're both equal to 0. That's a good thing. But doesn't look like something times something is equal to 0, right? So what do I do? Well, right, how can I get this to look like something times something is equal to 0? Everything we've been doing in chapter 6 tells us that the next step would be to factor this, right? So this should be one of the easy ones. The leading term is 1, which means I can go right to the parentheses, right? X times x, and I'm looking for factors of 15 that add together to give me 8, right? So if you know your multiplication facts really well, you know that that would be a +3 and a +5. And now these look like all the rest of the problems. Something times something is 0. Once I have the problem set up that way, I can now set each one of those things equal to 0 and solve. All right, so my two answers here should be x equals -3 and x equals -5. Remember, on a graph, these would be the x-intercepts of the graph. So E is very similar. I will leave that one to you to try. How about letter F? When I look at F, right, we need all of our quadratics, right, so our leading term is x squared, to be set equal to 0, not 18, right? All of these problems should be set equal to 0. So before I even attempt this problem, I will rewrite it, and that's going to mean moving 18 to the opposite side, right? How do we do that? Subtract 18 from both sides. The problem I'm actually going to be working with should look like this. X squared plus 7x minus 18 equals 0. Now this should look really familiar, right? Something times something is 0. What are those somethings? Well, x times x is going to give me the x squared. I'm looking for factors of 18 that are going to subtract to give me 7. My signs are going to be different, right? So 9 and 2 are going to be my factors, and I need to end up at a +7. A +7. What are my signs going to be? A +9 and a -2. And we're ready to solve. X plus 9 equals 0, or x minus 2 equals 0. My two answers here should be x equals -9 and x should equal +2. All right, great. Let's try one more, and then I'll do a part B for this video as well. Alrighty, letter G. Okay, letter G. It's a quadratic. It's set equal to 0. That's a good thing, which means I can start. This is not a trinomial, it's a binomial. So I'm not looking at any last term trying to figure out what is going to give me a 6. Okay. In fact, when I look at this problem, I ask myself the same as I start every problem with factoring. Is there a GCF? And for this one, there is. The GCF is x. And what's left in parentheses is the x minus 6. This problem is set up nicely in that Something times something is equal to 0. What does that mean? That means one or both of those things is equal to 0. My answers here are x equals 0, right? Or x minus 6 equals 0, which would mean that x is 6. Those are my two solutions here.